Well, now we're going to talk about this point. The last point here is sum and the difference of two cubes, okay? Factorization of algebraic expressions, sum and difference of two cubes. Now, before we start with the question, let's say something about the cube. You know, cubes are like, if I say a to the power of 3 is a cube because it's a times a times a. And then the formula says that when we have like a cubed plus b cubed, okay? Note that we said a squared plus b squared doesn't have a formula, okay? But a cubed plus b cubed has a formula, okay? We call it sum of two cubes. So this will be equal to what? It's gonna be a plus b in the bracket like that equal to a squared minus ab plus b squared. Okay, we must remember this formula. And similarly, a cubed minus b cubed, this will be equal to a minus b in the bracket, and then a squared plus ab plus b squared. So those formulas has to be remembered. I'm gonna write them here. A cubed plus b cubed, this is equal to a plus b, and then a minus ab plus b squared, okay? And then a cubed minus b cubed, this is equal to a minus b, and then a squared plus ab plus b cube. Now remember that when it's a plus here, it has a plus here at the beginning of in the first pairs of bracket, and then minus here in the second pair of brackets, and then when it's negative, it has a negative here, and then plus there. Okay, so let's start with the questions. Question 1. Question 1, we have like 27x cubed minus 1. So you notice that 27 is a cube number. It is a cube of 3. So we can write like, it is a cube of the number 3. It's like 3 cubed, x cubed minus 1 is also a cube number. It is a cube of 1. Actually, 1 can have any power. So this will be, then note that this is like our, because the power of 3 is common, we can write this like 3x, okay, to the power of 3, and then minus 1 to the power of 3, okay? And then we can apply the difference of two cube formulas there. Our a is like 3x, and our b is just 1, not negative 1, but 1. And then I can apply the difference of two cubes. This will be like 3x, okay, minus 1 in the brackets, open brackets, there's negative here, and then 3x squared, which is 3x squared is 9x squared, okay, minus ab, so 3x, maybe I should write everything. So I want to say 3x squared, this way, okay, a squared minus a b, no, it's plus ab plus b squared. Okay, that's the formula now. Substitute. So it's going to be like 3x to the power of 2 plus a is 3x, b is 1, and then plus b squared, 1 squared. Then this will be equal to what? 3x minus 1, and then 3x squared is 9x squared, plus 3x times 1 is just 3x, okay? Plus 1 squared is just 1, so that's the answer. Okay, so that was the answer of question 1. And now leave the summary. We did 1, the summary we can do 2 and 3. Okay, even 4, I'll leave that 4 for you, and then I'll do 5 for practice. 5, here, I'll write here question 5. That's a cubed b cubed minus 1 over 8. Okay, this can be written as a cubed. Here the exponents are common, so we can just write the power of 3 there, and then that's a b. Okay, because the exponent is common, minus 1 over 8. Okay, 8 is the same as 2 to the power of 3. And then one can also have any power. One of the law of exponents says this: a to the m over a to the m over b to the m. Okay, it's the same thing as a over b to the m. So this can be written as a b to the power of 3 minus a half raised to the power of 2. A half raised to the power of 3. Now we have difference of 2 cubes. Okay, so this is a cube, that's a cube. You can apply the difference of 2 cubes formula here. This will be then okay, a b, just like a minus a half, okay, in the bracket, and then open bracket. I use square bracket so long, square bracket, and then we have like a squared, okay, plus a times b, okay, plus b squared. Okay, and then a is just ab, ab, okay, plus a is ab also, b is a half, not negative a half, but a half, and then b squared is a half there. And then we can simplify this further. Ab minus a half will be equal to what? A squared b squared, okay, plus ab times a half is ab over 2, plus a half to the power of 2, so that makes 1 over 4. That's question 5. Now we can do question 6 similar way. There we can first take 5 as common factor, and then give like x cubed plus 8, and then over here we can apply the sum of 2 squares. Over here, sum of 2 cubed, I mean to say. Okay, over here also it's similar as 6. You can take 8 out as the common factor, 8a actually, because you can take 8a out, so it'll be a cubed minus 8, and then apply the sum of 2 cubed. And then over here we can take -1 out as a common factor, and it's going to be x cubed plus 27. Okay, and then apply the sum of 2 cubes. Okay, so I'll leave these ones for you to practice these. Okay, and then over here also 216 is the same thing as 6 to the power of 3. Okay, so don't write this in exponential form, but 1 over 27 is like 1 over 3 cube x cube plus 6 cube, and 1 over 3 is going to be like 1 over 3 raised to the power of 3 x cube plus 6 cube, and then apply sum of 2 cubed there, same thing as here and there, because this can be just x cubed plus 1 over x to the power of 3. That's going to be x cubed minus 1 over x to the power of 3. And then there, we already have 2 cubes here. This is like the first cube is 2 to the power of 3, and the other cube is a minus 1 to the power of 3. So I want you to go practice these questions by yourself, and then see practice this. Just follow the examples we did in question 1 and 2. Thank you. Now, question B says, consider x to the power 6 minus 64. 1 says factorize the above expression by using the difference of 2 cubes method. Okay. Now I'll move it up there. Question B1. We have like x to the power 6 minus 64. Now, we do know that x to the power 6 is, okay, it can be written as x, we can put the power of 3 there because the question says by using difference of 2 cubes, okay? So I can put the power of 3 there, and then within the bracket, I'll write x squared, knowing that this formula, a to the m, okay, to the power of n, this is equal to a to the m times n, okay? So if we times, here we can times exponent, it's going to be x to the power of 6. Now, minus 64 is same as 2 to the power of 6 also, okay? So this was 2 to the power of 6. We do the same thing. So over here, we will write the power of 3, and then there we write 2 to the power of 2. Now, this will be according the difference of 2 cubes. This is like my a, and that's like my b. So this will be equal to x squared minus 2 squared, which is 4, okay? And then I'll open square brackets. There I'll put a squared, that's the formula, plus a plus a times b plus b squared, okay? Then I can substitute the values of a there. A is x squared plus b is 2 squared, which is 4. Okay, that's x squared, and that's 4. B is 2 squared, which is 4, and then b squared is going to be 4 there also, and then this would be then x squared minus 4, the bracket like that, open bracket, x to the power 4 plus 4x squared plus 4 squared is 16. That's the method of that this is the 2 cube method, 2 cubes method. And now if I do question B, question 2, A2 says by using the difference of 2 squares. So x to the power of 6 minus 64. Someone can say, sorry, 64 is 8 squared. Sorry. Okay. We also know that this is 2 to the power of 6. We can say this because we talk about difference of 2 squares. I'll put the square there. Then within the bracket here, it's going to be x cubed. Same also. Over here, I'll also put the power of 2 there, and then within the bracket must be 2 to the power of 3. We know 2 to the power of 3 is just 8. Okay, this is like, it's like x cubed to the power of 2 minus 8 to the power of 2. Now we have like a squared minus b squared. So this will be x cubed minus 8, okay, in the bracket, and then x cubed plus 8. That's the difference of 2 square method. Thank you. Please, if this is your first time, subscribe to this channel, or if you've never been subscribed to this channel, give us a thumbs up, and then share the link, hit the notification button. Thank you.